Oh, and of course, today I'm also going to give you back your Sokotoa quiz because I have now marked it. Oh, and none of you guys told me in the past 3 weeks since we did the test that I hadn't put your Unit 1 test on to check my mark yet. So you guys all have like 8%. I was putting stuff in today for my grade 9s and I just clicked, oh, I wonder how my Honors 10 kids are doing. Click, 8, 7, what the hell? Oh, I didn't enter any of their tests yet. What an idiot. They're all entered now. So all of you have a grade. Now, some of you have a grade that is poopier than it should be. Because that instruction that I give you where you write the score for your review on your test because you don't want to publicize what you got on it, even though you tell everybody what you got on everything, but if you said it out loud, you don't want to do that. But if Luke were to ask Bronwyn what she got on a test, Bronwyn would turn around and say, I got 29 out of 34. Oh, but Mr. Myers, how dare you ask me what I got in public, so I have to say it out loud. Luke, I got 29! But whatever. I understand that you guys are nothing but a bunch of hypocrites. That's okay. Because you don't wish to publicize your grades, I need to get those grades. The easiest way for me to get those grades is for you to write them down on your test. A great many of you seem to have problems with that instruction. Perhaps because I didn't start with Simon Says, and you were worried that I was going to kick you out of the class. So, on your next test, there will be a Trig review score. Write it on the test, but none of you are going to. So now, Mr. Myers says, write your Trig review score on your test. Now you can all do it and stay in the game. Okay? Okay. We marked the Trig Sokotoa review, did we not? The one that looks like this.
Oh yeah, we marked that. Yeah, we did.
Well, Luke, you're the wrong person to ask, Luke, because you're a very busy man. You have very little time for math. I understand that. It's football season. But we marked this, yeah?
Yeah.
Okay.
That was the one with the airport.
The airport, yes. Okay, now I asked for you guys to do one question for homework. Now, I, of course, am not going to walk around the room and make myself feel bad and see how many people didn't do that one question. I'm going to do the other thing that teachers do and say, would anybody like to volunteer what they did for this question? Then the kid who did it can start us off and everybody else can be like, oh, really? That's brilliant, Jazz Curate. I did that too. And then the teacher says, that's totally wrong. Oh. I didn't do it that way. He's pretending to write and erase right now. Jazz Curate. The review. You need the notes. Yes. They have probably printed by now. Thankfully for all of you, Jazz Curate has had his binder stolen and he needs a copy of these notes, which means I have to go downstairs and get it from where it was printing. So anybody that didn't do that back-breaking amount of homework that I gave you last night can now quickly copy it from the 10 of you that did it. I'll be right back.
Like this.
After the angles?
Yeah.
Oh, I didn't do it.
I didn't make these.
I don't know where it went. It's getting
Hey, I'm too lazy to go fill it out.
low key though. I did
I'll fill it up there. It's empty. Or should I just go fill it out?
Why did that sound like a song? Like a second ago. Actually, there is a song. You know, by I wish you could film.
You can get rent like one.
They don't taste like anything different. I think the yellow ones are. The yellow and the orange. I like the orange. I
Hi.
You can have the favorites.
No, I was wrong. Well, it was not mine. Oh, I thought we were playing hangman. One letter word. A. No. It's either A or I. Oh. Now, so, how did we go about this? Well, we needed to find the three trig ratios. What are the three trig ratios? Sine theta, cos theta, and tan theta. And of course we remember from our notes that sine is y over r, cos is x over r, and tan is y over x. Not y over 8, you idiot. Y over x. Where do you see in this question x's and y's? -4 and 11 is an x and a y. Where can I put x's and y's? Anywhere I see x's and y's. So, sine of theta is 11 over r. Okay. Cos of theta is -4 over r. Okay. And tan of theta is 11 over -4. All right. Well, I've got my three trig ratios, but I don't, do I? Because I have an empty spot. I don't have a value for r. I have r. That is no good. How will I find r? I already told you guys, you do have all the tools you need to do this. Say it louder, Danielle. Pythagoras, of course, because -4, 11 is up here, isn't it? And that makes this triangle. -4 and 11. So how does that find me r? Yar! It's a hook. Because I'm a pirate. I'm a math pirate. Yar! So of course, you guys had to realize, oh, wait a minute. Doesn't then the square root of x squared plus y squared get me r? So of course you had to do that. That was the square root of 16 plus 121, which is 137. Now, read this question to me and tell me what word in there tells me what to do with root 137. What is the word in that question that tells me whether I can stop here or not? Tiffany. Exactly. Does 137 have a root?
No.
No. It's an irrational number, yes?
Yep.
So I can't go any further. So this is now what r is. Got it? So what is the sign? 11 over root 137. What is the cos? -4 over root 137. And what is the tan? Oh, tan was okay. Have I answered the question yet? No, I need theta. Which of these three is the easiest to use to find theta? Tan, because there's no root in it. It's nice and perfect, yeah? And how do I use tan theta to find theta? It's a shift tan situation, isn't it? Of 11 over negative 4. What happens to you when you do that? Second tan negative 11 divided by 4. I get negative 70. That's weird. Yeah? That's weird, isn't it? What's weird about that? It's negative. What? So this got me negative 70 degrees. Isn't this a reference angle? Isn't it? Because it has to be 90 degrees, right? So now all I got to do is figure out where I am subtracting that 70 from. Well, is tangent positive or negative? Read the question. Is tangent positive or negative? It's negative, right? Because it's 11 over negative 4. So I look back to my list and I see that for tangent to be negative, it has to be here or here, doesn't it? Which is the only one it can be in. Where is negative 411? Quadrant 2. So the 70 has to be in here, doesn't it? It has to be a minus 70. So it has to be right there. So this cannot be negative 70. It must be 180 minus 70, which equals 110. Now that looks like a lot of work. But what, if anything, there is new? Even if I didn't teach the whole lesson yesterday, is any of that beyond your ability to puzzle through to? Could I have sat down yesterday and given all of you 80 minutes to figure out that one question? Do you think you could have gotten close? You really don't? I think you would get very darn close because, of course, you would have said, all right, as soon as you saw negative 4 and 11, you should have gone, okay, negative 4, 11. Negative 4, 11. All right, I got to do trig. So I better make a right angle triangle. Okay. I know that this part was negative 4 and this was 11. So now I can find the hypotenuse. Once I have the hypotenuse, I can find all the angles. And once I find all the angles, you found this to be 70. You're smart kids. You know we start counting there. So this had to be 110. I didn't even need to teach yesterday's lesson. Technically, did I? I could have walked away and let you puzzle it through. Yeah? Is everybody okay with it? The reason I teach yesterday's lesson is because a great many of you, it becomes a little difficult to visualize bigger angles than 90. Right? And you need to understand that this 70 here is the exact same as this 110 here. Cool? All right. So now I am going to shut up for a minute and let you attempt number 3. You may work with your neighbor. I do not care. But I would like for you to go ahead and attempt number 3. Only number 3, because I want then to all of this. Okay, I'll wait a moment for you to soak that in on YouTube later when you're bored and have nothing to do. So I'm going to watch my math video. Lies. 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 Christmas is coming too. You're going to get me a big present, right? Lies. Okay, so everyone's cool with this? Okay, now, of course, you could also have done this. Tan equals y over x, yeah? If you're doing this algebraically, yes?
Yeah.
The point you had was 4, negative 3. Tan is y over x, so tan is negative 3 over 4. Then you can just do the work algebraically. You don't even need to draw it. Okay? Why have I given you both? Because of the analogy I gave to Victoria. The more mathematical tools in your toolbox, you're a mathematical tool, Myers, the better off you will be. Understand? Glad to see you back. Leave again. I dare you. Do I look like I'm smiling? Good. I'm glad you are picking up on the social cue that I am giving you. Everybody cool? I don't care which way you go about doing this. You need to know what works for you. I spent yesterday proving this so you could have that quickly a shortcut to do this work. I show you that because when you go further with trig in math class, this is not the end. Just like SOHCAHTOA wasn't the end. It goes on and on and on. So the more stuff you get this way without having to draw, the better off you're going to be. Okay? But I don't care which way you use. Understand? Okay, number 4. I did say to go on to it if you felt like it. And number 4 is very similar, yes?
Yes.
But not quite the same. So, sketch and determine the value of the standard position angle theta if tan is negative 9/5 and the terminal arm lies in quadrant 2. Okay. First of all, if tan's going to be negative, there's 2 spots it can be, yes? 2 and 4, because it's CAST, right?
Yep.
So it has to be in 2 and 4, but do we care about the one that's in number 4?
No.
We only care about the one in quadrant 2, yes? So if you're a drawing type person, you know that it has to be out here, yes?
Yep.
And you know that tan has to be opposite, so it has to have a rise of 9 over a run of negative 5, right? So if you draw that, there's your theta. So it's tan shift theta of 9 over negative 5, and that's going to give you your theta, isn't it? I don't have my calculator visible. You guys can do that part, yeah?
Yep.
So what is it?
119.
So your calculator gives you negative 61, right? So you go to because you know that's the reference angle. You go to the reference angle and you say it's negative 61. Negative is clockwise. So I go clockwise from my reference angle. This was 180 minus 61. So this part, standard position, is 119. Is everybody good? That's drawing it. How many of you are comfortable with drawing it? Okay. Now, to do it algebraically, tan theta equals, only one of them has to be negative, yeah? Right? So tan theta is y over x, yes? So you have to remember, okay, I know where this is. Because it's in quadrant 2, the x has to be negative, right? So, all right. So once I know that it's in quadrant 2, I can go shift tan. So there's my y, there's my x. Shift tan of 9 over negative 5 to get my answer of negative 61. Then I do still need the knowledge that if it is in quadrant 2, so it must be 180 minus the 61. If you're going to go the algebraic route, you have to be very comfortable with the Cartesian plane. Okay? Some of you are better with it than others. All right? Is everybody good? If you want my personal recommendation, it is do a bunch of these with sketches while you are getting used to it. Okay? Everybody cool? All right. Now, I want you guys to very quickly use your calculator to find all these to four. It doesn't even have to be 4 decimalists. It can be 3. I don't care. But just use your calculator. It'll take you 2 seconds. Find all of these. And you find them normally. Just however your calculator works. If it's backwards, you're going to go 43 sine. If it's forwards, you're going to go sine 43 equals. Okay? And we're just going to write them out. What's this one?
Decimal 68.
682. Let's go to 4.
6819.
6819.
Well, there's another 9 behind
So
that.
it's 68199, then it becomes
Yeah.
6820, yeah?
Yeah.
Okay. Cos 170. It's got to be negative because of CAST, but I don't know what it is. 9848. Great. Cos 350.
Decimal 9848.
9848. Tan 10. It's positive. 1763. Sine 223.
Oh.
Negative 0.6820.
6820. 317.
Negative 0.6819.
So another 20. 270.
Error.
Error.
It's just an error.
She
There.
says it? Oh.
Yeah, mine-
Some of you will have errors, some of you will have something else, but trust me. And 190?
1763.
1763. Now, you guys look at that, and the question I wish to ask you is, why are there pairs? And why are there opposite pairs? Talk to your neighbor if you wish. Explain those 2 questions to me. Then we'll talk about G.
Do you get it?
You get it? No.
Yeah. It's because, well, one.
Trust me, you want to put this into words even if you get it.
Reference angle.
Yeah.
One is the
Other.
standard.
That's part of it. Yep, good job.
Yeah, you go decimal technically.
You didn't write error.
It's my
Mine says domain error. It's because I didn't put a bracket. Opposite.
error. Another word I can't say. Like if I ever meet a pro, I apologize in advance for not being able to pronounce your name. What does it sound like I'm saying?
It's a good thing you two are friends. Because it would sound pretty awful to a casual walker by. Hello, Christina. Do you like your dinner? Is it delicious?
It sounds like Scooby-Doo.
You're the new Scooby-Doo.
All right. Can anybody explain to me either of these questions? The pairs or the opposite pairs? Would anybody like to tell us, explain it to us? Well, let's use E and F. They're the same, right? Right?
Yep.
So E and F. Sine of 223. Where would that be? What quadrant? Third. Down here, yeah? Everyone agree? Right? Sine of 223, because that's 180, and I got to go a little further, yeah? And sine of 317, where would that be? Fourth quadrant, down here, yeah? What's this reference angle? 43. What's this reference angle? 43. See it? Everybody understand? It's the reference angle that gives us our sine. The sign of the sine, positive or negative, is based on what we did yesterday, the y's and x's, right? So what's the other pair? Was D and H, was tan of 190, right? Where's 190? I'll do D and H. Where's 190? Well, there's 180, so there's 190, right? What's its reference angle? 10. And then E was 10. 10. Cool? And then C, A, S, T. Tangent, everything's positive in A, and tangent is positive here. Everybody get it? The pairs are usually not the problem. People have trouble explaining the opposite pairs. Well, why are the opposite pairs there? Well, B and C was 170 and 350, yeah? So B and C. 170 would be right here, right? Yeah? What's its reference angle? 10. This guy's reference angle is 10. C, cos has to be positive there, doesn't it? Because it's adjacent, and adjacent measurement is positive. And up here, cos's adjacent measurement is negative. Does everybody see it? Everyone is good? All right, so now try number 6 on your own. And then once you're done number 6, I'm going to give everybody a short break. I'm going to give out your assignment, and I'm going to give out the quiz and go over it. Because everybody needs to understand what an octagon is.
Like the one on the test?
That's
I figured it out after I finished the test.
like right after you handed it.
Yeah, right after I handed it in, I had figured it out. And then it bothered me. Because I couldn't fix it.
And then we fought over trigonometry.
No, that's good.
I know, right? We've been working on it all week, my family. We were having a fight last night because I made lunch for my kids. I made lunch for the kids, and my son left his lunch at home. It's like, I didn't think it was lunch for me. Like, why? Well, 'cause you put that bag of grapefruit there. That's not a grapefruit. That's an orange. Well, it looks like a grapefruit. But it's not. I know you don't like grapefruit. Why would I give you grapefruit? I don't know. So what did you do? Well, I thought I was still being punished, and I had to make my own lunch. I've been making your lunch for a week. Your punishment ended a week ago to make your own lunch. You haven't made your own lunch in a week. Why would you suddenly think, I don't know. Well, did you make a lunch? No. So we were trying to work out a word for meal so we could say, and then we fought over something for lunch, but we couldn't work out one. We were trying other languages and things, couldn't make it work. But it diffused the situation. Although I'm not making lunches for my son anymore. He's on another at least week of doing it himself. We'll see what happens. He will probably lose a lot of weight. Grade 7.
I still don't make my own lunches. My parents
Really?
do. Yeah.
My mom stopped making my lunch in grade 6 when I got a paper route. It's like, if you're going to be up at 5 in the morning and damn well make your own lunch. Okay, Mom. And then when I got to grade 8, there was cafeteria in the school. So lunch every day was nachos with electric cheese. My mom was like, what are you eating for lunch every day? Oh, Mom, they got a nutritious cafeteria. It's no problem. Everything's cheap. $2. Mom's like, okay, no problem. Nachos with electric cheese. And a dingbat.
A what?
A dingbat was an old frozen treat. It was chocolate wrapped in vanilla ice cream, dipped in, yeah, it was long. Huh?
Is it like that push?
No. It was like, you know what a Revel is? Ice cream with the chocolate on the outside? A Revelo? Yeah, it was like a Revelo, but it had a chocolate core as well. They were 55 cents. And the nachos with electric cheese were $1.35.
How much was bread at the time?
Huh?
How much was like bread or like everything?
I don't know. But when I was at university, I ran out of money on my card around middle of March. School goes to the middle of April. So for the last month, the university, 3 meals a day, 2 peanut butter and jelly sandwiches and a glass of milk. 68 cents. And a little block of cheese that may or may not have found its way into my pocket. I didn't say that. 3 meals a day, though. You can go pretty far on peanut butter and jelly and a glass of milk.
Did you know that cows are attracted to trombones?
Cows are attractive too.
The
Oh,
music-
are they?
Oh, yeah.
So if you walk around a field with a trombone doing sad trombone, wah, 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 the cows will come?
Okay, no, I saw this video on some YouTube
It's on his video,
and
it's a channel.
There's this video of a guy pulls out a lawn chair, sits in the middle of an empty field. It starts out empty. Then he starts playing the song Royals, and then over this hill comes a whole bunch of cows. By the end of it, his entire herd of cows
They're
is
not
sitting
even
there
like
watching him.
they're not even doing anything to him. They're just standing in a good lineup, like watching him.
I see. Weird. Alrighty, here we go.
I didn't even work on it.
Do I need to draw this? Do I need to draw it?
No.
No, I've been doing a lot of drawing, so I'm going to start this one algebraically. Everybody okay with that?
Yep.
All right. So sine is always y over r, yeah?
Yep.
Right?
Yep.
So that means in this case, it's either negative 2 over 5 or 2 over negative 5. Now, which one of those isn't okay?
-5.
Negative 5, right? Because the r has to be positive. Yeah?
Yep.
So this has to be our sine, correct?
Yep.
I only want theta, so I do shift sine of negative 2 divided by 5. And what does that get me if I do the trig? Negative 24, once I round it up, yeah?
Yep.
Right? So if it's negative 24, there's only 2 places it can be, yeah? Where? The first one's easy. C-A-S-T. Where's the only places it cannot be? It can't be there and it can't be there because signs are positive up there, yeah? So it has to be down here. So it has to be negative 24 right there, yes?
Yep.
What's that real angle? Because it's not negative 24. Go for Myers. Hey. Yeah. I can ask her. We're kind of in the middle of something, but... Oh, no, in a couple of minutes she'll be fine. Yep. Okay, bye. All right, so what is that really? Because it's not negative 24. What is it really? 360 minus 24, which is 336. Is that cool? Everybody's happy with that one, yeah? But there has to be a second one. Where's the only other place it can be? It has to be down here, yeah? Right? And it has to be where? Where's the 24? It has to be the reference angle, yes? Which is in here, right?
Yeah.
So what is this as a standard angle? How far is that? 180. 180 plus 24 to get 204. So this question was ambiguous, wasn't it? There wasn't just one answer because both of those have that sine value. Does everybody get it? Every angle has a buddy that has the same sine, cosine, tan value because they share a reference angle, but he also has a buddy that's reversed, positive and negative. On the other side of it's reflected across the axis. Some of you in grade 9 probably maybe did some reflections. Do you remember doing that in grade 9? Reflections, translations, and rotations.
Yeah.
And it seemed like it would never be useful to you.
Yeah.
This is where it starts coming into play. Because this is reflected across the y-axis. Everybody got it? Feeling good? Feeling strong? Okay. I'm going to stop my recording.